Watch carefully. This is what we call a burning wooden splinter. That means when you take this splinter and go and test the gas in the cylinder Q, this is what you need to use. Okay, so now we are going to go into the experiment of how we are going to do electrolysis. Okay, now it's very unfortunate that you are not able to carry out this experiment in school because of this virus, but normally your teacher would allow you to conduct this experiment because this experiment is very simple and you are able to collect the results very easily. Okay, collect the results very easily. But never mind, we'll look at the theory of how this electrolysis is being done. Now, during electrolysis, you are going to split oxygen and hydrogen. So what happens is you are going to collect, kutip, kita akan kutip gas ni. Collect, you are going to collect the gases. So what happens is oxygen is going to be collected at the positive electrode, or what we call the word anode. Hydrogen is discharged at the negative electrode, or called the cathode. So now I want to draw your attention to this picture first before I explain anything else. This is electrolysis. This is electrolysis. Inside a beaker, you are going to place water plus a bit of dilute hydrochloric acid. The reason why you add the dilute hydrochloric acid is because water is a poor conductor. It's a poor conductor of electricity. So if you see in the discussion here, I have placed the notes. Where is it? I have placed the notes here. Pure water is a poor electrical conductor, so acid has to be added. Okay, good. So acid has to be added. Now, let's go back to the diagram. You will be able to realize that there are two measuring cylinder covering here. This is measuring cylinder. Measuring cylinder, they terbalikkan. This is the normal measuring cylinder. They terbalikkan, turn it around. Terbalikkan the measuring cylinder. Now the base is over here. This is the base. Okay? So two measuring cylinder. Okay? What happens is you are also going to have two carbon electrode. So what happens is this whole stick is actually made up of carbon. So the word carbon electrode actually means carbon stick. So there are two carbon stick here. There are two carbon stick here. Okay, there are two carbon stick or carbon electrode. Don't use the word carbon stick. Don't ever use the word carbon stick. Carbon electrode. Now, at the carbon electrode, what happens is you are going to provide electrical energy. Because you're doing electrolysis, so you need to provide electrical energy. Okay, fine. So we provide electrical energy. Nampak kata? Battery. This is the battery. And we know that battery always have a positive terminal and at a negative terminal. One is a positive terminal, one is a negative terminal. Longer one is positive, shorter one is negative. Okay? Longer one positive, shorter one negative. So what happens is there is going to be two poles here. Over here, because it is connected to over here, that is why here is the positive side. Here is connected to the negative, that's why it's called the negative side. Boleh? Boleh? Apart from it being positive and negative, there are going to be two more names for this. The positive side, we give it the name is anode. Anode. The negative side, we give it the name called cathode. We call it cathode. Now, how to remember? I want you to remember that when you see positive side, you see anode. This anode means add, 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 tambah. Apabila kita nampak positive terminal ataupun kutub positif, remember the word anode. Why? Because positive means add. Add using A. So anode is also A. Boleh. The other one, automatic. Automatic will be negative. Positive, negative. One anode, one cathode. Simple. Alright? Simple. Now, third thing you must remember. Third thing you must remember is the gas that it collects. I want you to remember this. Pau. Okay? Cha sao bao. Okay, cha sao bao. Positive terminal is what we call the anode. The anode going to collect oxygen. So when you go to the other electrode automatic become negative, automatic become cathode, automatic become hydrogen. Boleh ke tak? Just remember the word PAO, P-A-O. Can or not? So if you want to check, positive electrode called anode, anode collect oxygen. Okay, correct. Negative electrode called cathode, cathode collect hydrogen. Settle. Okay, so electrolysis done. Alright, but now let's look into the experiment. Now, the aim of doing electrolysis is to determine the composition of elements in a water molecule. Okay, to determine the composition of elements in a water molecule. That means you want to know inside one water molecule what kind of atoms they have. What kind of atoms they have. So when you are doing this experiment, you are not supposed to know what gas. You are not supposed to know what gas is going to be produced. We are going to test them later. Okay, we're going to test them later. So materials and apparatus. Distilled water. Okay, inside your lab you're going to have, okay, in a bottle they can press one, distilled water. Dilute hydrochloric acid basically just means that it's a very weak hydrochloric acid. Wooden splinter, that means it's like a satay stick, satay stick. Matches, electrolytic cell, you see electrolytic cell, the name they make it so nice, you know. Electrolytic cell. You know what is electrolytic cell now? You know what is electrolytic cell? They make it sound so nice. You know what is electrolytic cell? Huh? You know what's electrolytic cell? You tell auntie, they don't know electrolytic cell. But if you say battery, they know battery. Electrolytic cell actually is battery. Okay? Electrolytic cell. After that, you are going to have switch. Okay, there's a switch over here. Measuring cylinder, which you will use to terbalikkan, to trap the gas. The reason why we're using measuring cylinder, because measuring cylinder is there to capture the gas. If you are going to do it without the measuring cylinder, the gas is going to be produced and the gas is going to escape into the air. Because we know that water cannot trap air. Water cannot trap air, or water cannot trap gas. When the gas comes out, the gas will escape. That's why we use measuring cylinder to trap the gas. Dropper, connection wires, and crocodile clips. Okay. Procedure. Apparatus is set up as shown in diagram. Okay, so you just draw the thing. Switch is closed for 10 minutes. So this one will take some time. Electrolysis will take some time. So that's why it says 10 minutes, you will close. It's not like suddenly you turn on, boom, the whole thing. It's not like that. You turn on, you must wait. You turn on, nothing happen. You can see maybe small bubble, but nothing happen. Just wait. You just wait. You just go take a good coffee, you come back, then got result already. Okay? Switch is closed for 10 minutes and the changes are being observed. Okay? Then after that, the switch is open. After 10 minutes, you open the switch. That means open. Close the switch means you turn on the circuit lah. Buka, turn on the circuit. Switch is open means you lift the switch. That means you close the circuit. That means you open the circuit. Okay? You open the circuit. You turn off. Close means turn on. Close means turn on. Okay? Close means turn on. Wait, what is the water? Close means turn on. Wait, Close means turn on. Open means turn off. Okay? And volume of the gas in both the measuring cylinders were recorded. So what happens is you are going to have the measuring cylinder here. You are going to have the carbon electrode here. And then when you are beginning, the water is going to be here. The water is the whole thing. And then slowly, what happens is you will realize that the water will reduce. The water will become here. This water. What is this space? Gas. The gas collected in measuring cylinder P is tested with a glowing wooden splinter, while gas collected in measuring cylinder Q is tested with a burning wooden splinter. Now I want to let you know what does the difference between a glowing wooden splinter and a burning wooden splinter. Before that, before I do my magic, please watch. The cylinder P is going to be the what? Let's see, cylinder P, let's agree on this first. Cylinder P is going to be the positive. Okay, so we know that cylinder P, that's the Cylinder P. Maksudnya cylinder P is the positive side. Q is the negative side. Okay. So what we are supposed to know, what we are going to know is that the positive side will produce oxygen. Negative side will produce hydrogen. Okay, so let's see the difference between a glowing wooden splinter and a burning wooden splinter. Watch carefully, yeah. This is what we call a burning wooden splinter. That means when you take this splinter and go and test the gas in the cylinder Q, this is what you need to use. This is what we call a glowing splinter. Do you see that? Do you see down is a bit red color, but it's not on fire. This is what we call a glowing wooden splinter. And this is what you will use for cylinder P, or use it in the one on the anode, on the positive electrode. Do you see it glowing? Do you see it glowing? Now, when you use the glowing wooden splinter and go and test it, you go and test it inside the cylinder P. What are you supposed to see? Let's look at the observation. The observation when you test for the oxygen, here is oxygen, here is oxygen, and here is hydrogen. When you test for the oxygen, which is this one, glowing wooden splinter, you should be able to see that the glowing wooden splinter, it will light up again. It will light up, it will rekindle. Okay? It will rekindle. So it will start to light up again, rekindle. Lighting up again means rekindle. This is now red color. Now it's red color. But when you put it inside the P, it will rekindle. It will light up again. Okay, but now I don't have oxygen. Okay, of course I cannot show you. But it will light up again. Okay. But for the Q, how about the Q? Burning wooden splinter. When it is burning, you go and put it inside the measuring cylinder Q. What happens is you are going to see that it stops burning and it will produce a pop sound. Okay? It will be like this. It will be burning. Okay? It will be burning, and you're going to put it inside the Q. Pop. It will pop and then it will glow. It will extinguish the fire, or the fire will stop burning. So what happens is, that is actually what we are going to call, wait, I better put this somewhere. It's not later my house burn up. What happens is, that pop sound actually is a small explosion. I want to let you know. Okay? That pop sound is actually a small explosion. It's actually a small explosion. That's how you are able to hear the pop sound. Why? Because you know that this is hydrogen gas. You put the thing into the gas, into the hydrogen gas. What happens is, the hydrogen gas is actually an explosive gas. The hydrogen gas is actually an explosive gas, meaning it will explode. That is why you have hydrogen bomb. This one is only wooden splinter, no, chopstick, no. The one people make hydrogen bomb, to bomb a whole country one, no. They will use the hydrogen bomb and it will explode the whole city, It will explode the whole city. Bomb. That's why you are able to hear it produce a pop sound. Using burning, one is glowing, one is burning. You don't change. You change is not going to give you the result you want. You must do glowing for oxygen, burning for hydrogen. What happens to when it's glowing? Glowing, what happens? Glowing, when you put inside oxygen, it will light up. When it is burning, you put inside hydrogen, it will stop burning and it will produce a pop sound. Now you ask me, what happens if there is no oxygen? What happens if you put a glowing wooden splinter into something that is no oxygen? It won't light up lah. It won't light up. Or the other word, it won't rekindle. It won't rekindle. Because got oxygen, then it will light up. No oxygen, no light up lah. Then how about the burning wooden splinter? A burning wooden splinter, you can put, if got hydrogen, it will stop burning and pop. If it's not hydrogen, what happens? Put there, it will continue burning. If you got hydrogen, stop burning, then no hydrogen, continue burning. Okay? Can. So it's just if got the gas, then it will give you the result. If no gas, it will not give you the result. So you must just remember, oxygen, glowing wooden splinter. Glowing wooden splinter, if there is oxygen, will light up. If no oxygen, will not light up. How about hydrogen? Hydrogen, burning wooden splinter. Right? Burning wooden splinter. Burning wooden splinter, if there is hydrogen, will stop burning and produce a pop sound. If there is no hydrogen, what happens? It will continue burning. Boleh? I want you to observe the volume of the gas. Observe the volume of gas. You will be able to see that for the P, which is the oxygen, is a 2 ml. Okay? And for the Q is a 4 ml. Do you see that? It is actually, P is actually half of Q. And Q is actually double of P. Double of P. So, what happens is, we need to understand why is the volume different? Why 2 and 5? Why 2 and 4? Why 2 and 4? Why not 1 and 3? Why not 5 and 6? Why not 4 and 5? Why not 4 and 7? Because if you remember, we told you that the water is made up of H2O. That means there is 2 hydrogen and 1 oxygen. So when you separate the H2 and the O, is it true that inside here you are supposed to have 2? Inside here you are supposed to have 1? Correct or not? Then if I continue writing, do you realize here become 2, here become 4, here become 3, here become 6? Do you realize? Do you realize if you continue writing here 4, here become 8, here become 5, here become 10, here become 6, here become 12? Do you see that? Maksudnya apa? Maksudnya, when there is 1 oxygen, there is 2 hydrogen. When there is 2 oxygen, there is 4 hydrogen. So now here, how much is oxygen? Oxygen is 2. That's why hydrogen is 4. Because hydrogen atoms is double of oxygen. That is why the volume of the gas will also double of oxygen. Boleh? That's the reason why. Because here inside is the product of 2 atoms. Here is the product of 1 atom. Okay? So Q is double of P. Or hydrogen is double of oxygen. Okay? So as you can see here are a few notes. Pure water is a poor electrical conductor. So acid has to be added. Okay. The reason why you add the acid is because acid is a good electrical conductor. Okay, acid can conduct electricity very well. So that's why you add a little bit acid to help the water to go through electrolysis. Because the only way for you to separate or split this atom is when you are passing through electricity through the water. So if the water cannot pass through electricity, that means no electrolysis. If you want electrolysis to happen, you must let the electricity pass through. So you put a little bit of acid. That's why you use the dropper. Nampak ke tak? That's now the dropper. Where? Dropper. There. Dropper. That's why you have the dropper. Dropper to what? To drop your eye. No, to drop the acid. Drop acid into the water. So that is why you put the acid to increase the electrical conductivity of the water. Boleh? Okay. Ratio of the oxygen gas to the hydrogen gas is 1 to 2. Same as the ratio of atoms. Okay, this is basically saying that if the gas here is 2, here is 4 lah. Like what I explained just now lah. If the oxygen gas is a 2 milliliter, this is ml 2 ml, hydrogen 4 ml, oxygen 3 ml, hydrogen 6 ml, oxygen 4 ml, hydrogen 8 ml, 5 ml, 10 ml, 6, 12, 7, 14, 8, 16. Boleh? Okay. What is the conclusion? Conclusion is water molecules are made up of 2 hydrogen atoms and 1, here is wrong, oxygen atom. Okay, boleh ke tak? Can So please make that correction, sorry, it's oxygen, not hydrogen. 2 hydrogen atoms and 1 oxygen atom. Okay, make sure you change the oxygen, don't make it wrong. Here is oxygen, please, be careful, oxygen, change.